Hello there, this is Daniele from Toolchefs and welcome to this new video. So today we're going to have a look at the new Locomotion feature which is available in Atom since version 5. It has been improved and gone through a few iterations, and I'm showing you this video with Atom's VFX 5.4. So Locomotion is a system that is used for blending different animations based on some inputs. In Atoms we use 3. These inputs are basically 3 metadata that are attached on agents, and they represent the linear velocity of the agent. So basically this is the target velocity that defines how fast you want your agents to move. Then we have an angular velocity that defines how fast you want your agent to turn. These two velocities are per second, and then we have also another one, which is basically what we call the frame angular velocity, which is basically the variation of the direction per frame. So this basically would be an angle, the angle between the variation of the direction at this frame with the next frame. And then basically this last input is used for playing unsync clip. So we're gonna have a look later what this means. These metadata are usually modified by behavior modules. They can be modified by your custom behavior modules or by a behavior tree. And in this video, what we're going to do is we're going to have a look at the initial setup that we provide with Atoms, but in the next videos, we're going to also set up a new Locomotion system from scratch. Okay, so let's open the Atoms UI, and let's go under the Locomotions tab, where we have already an asset, which is shipped by default with Atoms. Here I'm on a 4K monitor, so I'm just going to increase the font multiplier to 1.5 so we can see the text here. So you see here we have a graph. This graph defines our Locomotion system. As you can see, there are different, we have several vertices, several points, and these points are connected and they create some triangles, okay? So all of these points are actually animation clips. So if we go on the animation clip events tab, we'll find them all here. So we have the man walk, man jog, we have the man idle loco, so man idle loco, man walk, man jog, and also the same happens for all the other clips. So they will be all in the animation clip event. So basically you first need to set up your animation clips before you can actually build a Locomotion asset. Here in this graph we have two different kind of points. So we see we have circle ones and square ones. The circle ones are what we call standard clips. So these are clips that can be blended together and still produce a good animation quality. And then we have the square ones, which are what we call unsync clips. These clips are played separately and cannot be blended with other clips. So for instance, if we check the man walk left 180, so this one, if we scrub the timeline, we see that the agent is basically walking and then turning 180 degrees while it's walking, okay? So to achieve this kind of animation and to have like a good quality while we're simulating, we really need to play this clip by itself. You wouldn't be able to, get this kind of turn by blending different clips together at the same time. So that's why we introduced the concept of unsync clips. Usually these turns are handled by the behavior modules, or you can even handle them by with your own custom modules or with a behavior tree. So for the unsync clips, we have some settings. The settings for all the clips are the same, but the blend frames and wet frames, they don't make any sense for the standard clips. But for the unsync clips, we have blend frames. So this is in and out. So while we start playing the unsync clip, we get like a transition of 5 frames, and then also a linear transition of 5 frames while we get out of the clip. Of course, you can change them, and just to make sure that you achieve the best animation quality for your Locomotion system. Then we have what we call wait frames. This new field has been introduced in Atoms VFX 5.4, and there's of course just specific again for unsync clips. So you'll notice that while you're playing with the avoidance or other behavior modules, sometimes, depending on the scenario, so maybe you have a lot of agents in a very area, and that area is very dense, the variation of the direction of each agent per frame could vary a lot. For instance, it could vary, the agent separation or the agent avoidance could say to an agent, turn 180 degree, but then the following frame could say, oh no, actually, you could actually stay on this direction, okay? So whenever that happens, basically you would see you would see like a little bit of jittering, right? If we don't have the unsync clip, so you would see the agent turning 180 degree and then going back to the direction that it was traveling before. And whenever you want to make sure that your unsync clips are not played straight away, whenever you have this kind of variation of 180 degree, or 135, really depends again on the unsync clip. You can provide a number of frames that you want to wait before you actually play the current unsync clip. So for instance, let's say an agent avoidance is making your agent turn 180 degree, and if we change this value to 2, we would say just play the man walk left 180 after this variation has been constant for 2 frames. Okay, so if the agent avoidance is actually telling to the agent to turn 180 degree for more than 2 frames. Usually we set all the values for the wait frames to 0, because you really want to make sure that these like the change of animation happens straight away. But again, it really depends on the setup. So if you really need to tweak this, there might be scenarios where you might be need to tweak this setting, the wait frame, in order to achieve like a better simulation for your scene. So all these nodes, you see they are in a position. So here we have 275 and let's pick the jog, 275 and 0. So this one, so the x value is actually the linear velocity, and then this one is the angular velocity. Both of these values are velocities per second and not per frame. And basically, whenever we're gonna tell atoms I have a target linear velocity of 275, it will mean that atoms will have to play the man jog clip. Again, if the angular velocity is 0. If, for instance, it's 90, it will pick the man jog left. And then if it's a value that basically falls in between, atoms will find the right triangle and then play the right triangle where the the input point that we're providing is placed, and then it will actually find the right weights for all the clips and mix them together. Okay, so if we go to the animation clips, just to have a bit of a talk about the clips, you see here we have a Locomotion folder which contains most of the Locomotion clips. We have some other clips like the jog, the walk, and so on that are here because they're also used by the state machines. So these are our standard clips. There are a few things that you have to keep in mind while you're building your Locomotion system. So the first one is that all the clips must have similar frame ranges. And with this I mean the standard clips, not the unsync clips. This is because while Atoms is blending the clips, if the frame range vary too much, then it means basically the result that we'll create they won't be great. So you really need to have like the frame ranges of each clip that you're using in a Locomotion system to be similar. So in this case, for instance, for the man jog we have 24 frames. For the man walk we have 34. And then we have for all the others, for instance, let's check the man idle loco, we have 50 frames. So these are not the same, but this kind of variation is acceptable. If for instance we have the man idle, which is like 300 frames, by playing this clip you will actually never be able to blend the idle with the walk properly. You really need to have again the frame ranges to be similar for the clips that you're using. Also for all your clips they need to have like the same number of cycles. So for instance, here we have 36, so let's go to 36, 36 to 70. So you see it's just one cycle, and all the other clips that we are using in our Locomotion are actually just one cycle. And all the clips needs to start with the same foot down. So in our case will be the right foot. And finally, for the turning clips, you need to make sure, so for your turning clips would be, which one? Man walk left 45, for instance. This one. They need to have the direction type set to local. And then the axis here for the direction would be, just activate it, would be the axis of the axis that is facing the direction where the agent is walking. So in this case would be the Z axis. This is because by using this value and not using a static value, Atoms will calculate the direction of this clip during the simulation, and then you'll be able to achieve a good animation quality. If you keep this to static, it won't work as good as if you were using the direction type to local. Also, another thing, whenever you're using unsync clips, we recommend them to have not loopable. It's really up to you, but you know, like you can even have them loopable, but usually we recommend not having them loopable. Going back to the locomotion, there are a few other things that we need to know. I mentioned earlier that these values represent the velocities of the clip. So whenever we're gonna see later, whenever we drag and drop a clip in here, Atoms will place the clip in the right spot. It will evaluate the average linear and angular velocity for that clip, and then we'll place the clip in the graph. It's important to understand that all the velocities, even the velocities that are evaluated by Atoms, are approximation. And with this I mean that the velocity of a specific clip, for instance the jog, is never constant for the entire frame range. It varies, right? But when building the blend space graph, we're actually setting an approximation, because again, the blend jog doesn't really travel at 275 units per second all the time for the entire frame range. So this is something that you have to keep in mind, you have to understand. You can of course always go in here and you can start tweaking the graph to achieve basically as you like. You can artistically change it and to achieve the best result that possible. A couple of other things to know is that Atoms doesn't really like when you have like very narrow triangle like this one, so you always have to try and make the best triangle possible. So let me Ctrl Z a few times so it goes back. And one final thing, the locomotion system works better whenever you have the root of the skeleton between the feet of the agent. So for some animation clips, like for instance for our agent type, for the man, and for all its animation clips, this is not actually true. The skeleton doesn't have the root between the feet. That's why also we have what we call the virtual root. So the virtual root is like a virtual bone that gets created and gets handled by Atoms. As you can see here, we are providing a position for the virtual root, which is -101 on the Y. And then if you go here in animation clips, you will see here that that joint is also here, and basically it gets it's animated really depending on the values that you set here for the virtual root motion. We have separate videos for the virtual root, so I would recommend going and check those videos if you're interested into this feature. Thanks for watching, and see you in the next video.